Hello everyone. We can use F-test to compare multiple means. This F-test is usually part of the analysis of variance or ANOVA. So, what is ANOVA? These are the aims of the lecture. As suggested by the name, this method deals with variances. We compare the among and the within group variances to test for the difference in means. These methods allow a hypothesis test for comparing means from multiple treatments without incurring multiple comparisons problem. When the number of treatment is 2, ANOVA is equivalent to a two-sample t-test. The null hypothesis is all means are equal. The alternative hypothesis is not all means are equal. Or at least one mean is different. Remember, the alternative hypothesis doesn't mean all means are not equal. It does not mean the alternative hypothesis states that at least one mean is different. We don't know which one. We use the F-test, the ratio between among groups and the residual variances, to test this. If this ratio is larger than 1, the difference among group means is larger than the one expected from random variance. Let's use some examples to explain this modeling concept. Based on this information, we can model this data as where yi is the tips for the eye check, mu is the mean of the tips from the 90 checks, and epsilon is the residual. Note that in maths we can use any symbols as long as they are properly explained. We found that the mean of the tips from these 80 checks is $50. So we expect that a random server in that restaurant will receive $50 tips on average. However, some servers could get less or more than $50. The discrepancy between the model and the actual observation is known as the residuals. We have residuals because our model is never perfect. The model becomes where Yij is the ith tips for sex j, mu is the grand mean of the tips, tau j is the effect of sex j, and epsilon ij is the residual. The mean from the 80 checks is the same as before. The mean from 40 check for female is $70. and the mean from the 40 check for males is $30. So based on this model, we expect a female surfer will receive $70 tips on average, and a male surfer will receive a $30 tips on average. Thus, a female surfer on average will receive $20 more than the grand mean. And a male surfer will receive $20 less than the grand mean. Again, there is residual effects as not all males or female surfers receive the same tips as the model suggested. So now we can improve our model by adding drawing happy face as another predictors. The model becomes where YIGK is the I tips for sex J and happy face K, mu is the overall mean, tau J is the effect of sex J, beta K is the effect of happy face K, and epsilon IJK is the residuals. The overall mean, the mean for females, the mean for male, the effect for female, the effect for male, the mean for checks with happy face, the mean for check without happy face, so the effect of happy face, and the effect of without happy face. Based on this model, we can calculate the expected tips by adding the appropriate effects. For example, a female surfer who drew a happy face is expected to receive $100 tips. Again, this is the expected tips based on the model. A female surfer who drew a happy face could receive more or less than $100. Thus, we have the residuals as the model is not perfect. Both ANOVA and linear regression use additive linear model. They both also use the least square methods. So, what is the difference between ANOVA and linear regression? The difference between these two methods is on the type of explanatory variable. Linear regression, quantitative explanatory variable. ANOVA, categorical explanatory variable. The assumptions of ANOVA are similar to the assumption for the linear regression. In regression, this assumption is known as homoscedasticity. What would happen with the analysis if these assumptions are not met? We can still do the analysis even when any of these assumptions are not met. However, we have to be careful when interpreting the results and making an inference. We can visually assess this assumption based on the residual plots. A normal QQ plot is used to assess normality. If the normality assumption is met, all points should fall approximately along the reference line. A residual versus fitted plot is used to assess homogeneity and the independence of variance. If the assumptions are met, we expect no evidence of relationship between residuals and fitted values. For small data, it is often difficult to evaluate these assumptions. A skeleton ANOVA contains all the predictors in the linear additive model with their associated degree of freedoms. We use skeleton ANOVA to check the model before the analysis to make sure that we capture all predictors. To check the output of the analysis to make sure that the analysis was done correctly. The source is the list of all predictors. The degrees of freedom is the list of the degrees of freedom for each predictor and must sum to the total degrees of freedom, which is the total number of observations minus 1. We use one-way ANOVA when we have one categorical explanatory variable with two or more classes. In one-way ANOVA, we model the response variable as the sum of the grand mean and the effect of these explanatory variables. Therefore, we partition the total sum of square into the sum of square due to the group means and the sum of square due to the residuals. The result of ANOVA is usually presented in ANOVA tables. This ANOVA table contains source, degree of freedoms, sum of square, mean square, the F statistic or the p-value for the F statistics. For one-way ANOVA, the source is among group and within group or residual. The degree of freedom of the group is the number of group minus 1. The total degree of freedom is total number of observation minus 1. And the residual degree of freedom is the difference between the two. The sum of square of the group, the sum of square of the residual, and the sum of square the total. The mean square is sum of square divided by degree of freedom. So sum of square of group divided by the degree of freedom. Sum of them of residual divided by the degree of freedom of residual. The F statistic is the group, the mean square of group divided by the mean square of residual with the degree of freedom of the degree of the group degree of freedoms and the residual degree of freedoms. Do you notice that the formula for mean square is the same as the formula for the variance? The residual mean square is the pool variance across group. Do this formula look familiar? It is the formula for the sum of square when we are calculating the variance. We can calculate each sum of square by hand, but we are most likely to use software to do so. Let's do an example. Before starting the analysis, we should always start with the skeleton ANOVA. The null hypothesis, we have three groups. The alternative hypothesis, not all group means are equal. These are the result, the sum of square. So first we compare the skeleton and the results. Now we can calculate the mean square. We can calculate the F. Can calculate the p-value for F using R or Excel. Or we can find the F critical for 5%. Because the p-value is greater than 5%, or because the F statistic is less than the F critical, we don't have enough evidence at the 5% significant level to reject the null hypothesis. Always do the skeleton ANOVA before running your analysis. Now, can you do this?